Failure here has low stakes and low consequences and lots of opportunity for time to remediate and recovery. Failure when you go out in the real world has much more significant consequences and economic impact. When we start to look at how we approach presenting materials, we always make sure that all of our concepts, whether they be something that's more programming or something more in the abstract, get grounded into a real physical construct, because that really gives our students the opportunity then to understand that holistic approach, that it takes all of those different cyber physical components to make a real system.
The highlight of working in the lab is really, this is just a giant sandbox. It's a giant play place for me and the students to explore the different technologies, see what's possible, and get hands-on with this equipment. But because everything up here is not fully optimized by intent, this being an instructional facility, they're having fun getting to see the equipment, but at the same time, they're helping me solve the same real-world challenges that manufacturers are experiencing in terms of troubleshooting and maintenance and integration issues. They're getting the exposure to all of that during their 4-year career here. So the big challenge with integrating systems rather than just strictly working on the component level is you're often dealing with many different vendors. And you're working in an environment where you have dissimilar technologies that you have to now try to figure out how to get them to work together.
When you actually get to work with these systems and program the robotics, you see like, oh, these types of robots have different ways that they are programmed, and sometimes those are incompatible and they don't talk to each other. So how do we get them to talk to each other? So it's experiences like that where things don't work out exactly like they do in the theory world that makes having that hands-on experience really beneficial, especially when you're moving into the workplace where everything isn't perfect and you don't have all the tools that you would like. You have to work with what you're given.
Because everything in this lab is actual real equipment, real devices, real components that you would see in industry. So not only is it of a specific brand, maker, model, but it's really a wide variety and breadth of different manufacturers of different types of equipment that students get the full breadth of exposure to those devices.
Everything you see here is in fact real world. Everything that the students get trained on is easily transferable to what they would see in a typical factory or in a typical industry. Yeah? So this is almost one-to-one mapping of what they would find in a real company or in a real commercial setting. And that is invaluable, because we tell our industries, you don't necessarily need to spend a lot of money on retraining our graduates. These people are ready to go, ready to employ.
When we look at working with our industry partners, one of the things we really look at is making sure that we are doing our due diligence to make sure that we have good partners that are going to be well positioned in the market, because those are also going to be those partners that are going to be bringing the technology most likely to be adopted in the market.
Understanding what's out there, what's in the field, that there's not a single solution to these problems, right? So what's the best single solution may be dependent on the individual components or devices that you use, whether it's from a design perspective of designing a system like this, or even from a maintenance perspective, maybe it's from a troubleshooting or continuous improvement perspective. But what's out there, what can I actually integrate into an assembly line or any sort of manufacturing equipment? And what are the pros and cons, right? We're bouncing between financial cost and maybe quality, maybe it's safety, whatever those different criteria are, we need to balance all of those. So understanding what's available to them, having an understanding of all those options is really critical when you're out in industry.
So the current products from Phoenix Contact that our students use, the main one is the AxioLine 2152 PLC. We use that within our introductory class. They'll get exposure to the PLC Next Engineer software, and they'll do basic PLC programming in that, as well as utilizing the HMI web server capability to start building out HMIs and dashboards.
And the Phoenix Contact PLCs have built-in OPC UA capabilities, whereas like some other PLCs that we use actually don't have that. So it's lowers the bar. Instead of having to set up an OPC UA server and manage all of that, you can start it up on the PLC itself. And then where you're writing your code and doing all your PLC control stuff is also right where you're running your OPC UA server.
We have some power supplies, we have network switches, control relays. We also have thousands of Quattro terminal blocks. The great one thing I'll say about the Quattro terminal blocks, those have been workhorses for us, and they're extremely robust. Typical terminal blocks maybe get cycled 10 or 20 times in their whole lifetime. These are being cycled 100 times a day, 40 weeks of the year for years, and they're still going strong. The technologies that Phoenix Contact are trying to present to companies now, that's what we need our students to already have exposure to, so that they can be the ones to bring that in to the new facilities.
Phoenix Contact's been a great partner with Purdue University over the years, and we are always happy when we have a chance to interface and to talk and to discover and see what the next opportunities are. So we're very glad you're here, and we appreciate all the time, energy, and effort you guys have put into the partnership.